So today we're going to try to render multiple shapes, and we're going to start with rendering a purple, right? So yes, so and then I'll use Helix this time. Test.py, cool. So single shape test. So the RGB color is there. Step 1, let's edit the write to memory, right? X yank. I'll make a new function for this. I'll make a new function. So we have write to memory here, and I'll have and then we're gonna have async def, and I'll call this write color to memory, and we'll take obviously dude, the mem, the address, and then the color. And obviously color spelled with U because we're in Canada, right? This is a Canadian stream. This is right as you do, right? And so now, yeah, we have these, and so what we're going to do here is we're gonna start by writing to memory at the address, and well, obviously dude mem address, and then from here so dude mem address, and then for data we're gonna have color of 0. So used to the Vim keymines, you know. Cool, there we go. And then color of 1, color of 2, and yep, dude mem address. We have to do address plus 1, address plus 2. Cool. And so yep, all of it sits in there. So then we're gonna await a write color, write color to memory, write color to memory, and then this is going to have dude mem. The address is going to be 2 to the 23 plus 128 times y plus x times 3, because again 3 per, and then the color is going to be I'll set up a color here. I'll have the color of the shape to be let's have a nice red and blue. Let's go very red, maybe some green, and then a decent amount of blue, right? Like a nice light. This might be a pink, I don't know, let's find out. And so this is going to be color of 0, color of 1, and color of 2. Cool, great success. Now we're there, and here we're just going to write in the color. Great, amazing. So now we're writing the color to memory, and now let's see if this make dash b waves equals 1. Oh, right. So let's activate and make dash b waves equals 1. Cool. And now we're running it, and so this should theoretically work because we're using the colors that are available to us. We failed. Hold on. It's write color to memory. Write color to memory. Write to memory is missing. Why is write 1 2 3 4 5 1 2 3 4 5 1 2 3 4, and then write color to memory 1 2 3 4. What is the problem here? Oh wait, it's here. And then the size of this. Yes, this is 1 byte, 1 byte, 1 byte. Cool. There we go. Make dash b waves equals 1. Oh, something fell. And so we failed this one. Okay, we have an error. We're outputting 96. Okay. And then we are expecting it to equal 1 in read from memory. Line 26. What? Right, oh, never awaited, okay. Yeah, okay, that checks out. I forgot to await here, rip. Wait, because this is asynchronous programming, of course. I don't know why this stuff is all asynchronous, but, you know, it is what it is. It is what it is. And so we run it. And then Okay, this is a great sign. This means that it's running perfectly well. And then we can see the color on it after it renders. And so what we're going to do is we're going to try to set up a multicolor background. Ah, there we go, it passed. And so then if we reload the image, it... Oh. No, it is showing up. Nice, see? Okay, that's strange. That's very strange. Yeah, so we have nice pink square. Okay, it's not showing up here. Fresh, choose file. Yeah, it is here. Yeah, we have a nice pink square. This is great. I love pink squares. And then, yeah, now we just have to have it do multiple shapes, right? So, single shape test. Yeah, so copy that all down, yank it, paste it, and this is going to be called multiple shape test. I'll call this, I'll rename this from single shape to single square, and I'll call this multiple square test. Right? Cool, there we go. We have multiple square test. And so, there's one shape in memory. No, there is two shapes in memory. And so you have the square. So we're going to start with the background square, right? So the background square. Hold on. So we're going to have the a second square. Let's say middle to mostly bottom right corner. So let's say because it's 128 by 128, right? And so what we're going to do is we're going to start with from 64 to let's just say 100, and then 64 to 100, and here there's going to be 16 to yeah, let's say 16 to 96. I don't know. Let's keep this at 3296, a nice central square, and one that goes from here to. No, let's have it go on to the bottom right corner. Right, that's probably it's what like this specifics here doesn't matter. 128. 128. Cool. And then the colors. Let's say this is color 1 and color 2. I'm just gonna swap the red and the blue. And so empty, 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 empty. Yep, and we're gonna have no, because again this thing. Oh come on. Okay, whatever. Bounding box from 64, 64 to again. Documentation is good. Documentation is good, right? 120, 128. Cool. And then here we're gonna go with color 0, color 1, color. Oh wait, we have numbered this 1, 2, 3. 1, well 1, 1, 1, 2, 2, 2. And then we go 2, 2, 2, and then RGB color. I mean, we know what it is. It's self-documenting that bit. And then here is just going to be 0, indicating type of this is a rectangle. Cool. There we go. And while we're in here, if we're in between, so we're going to start with two if statements, right? So step 1 is if we're out of the first. Well, this one has to happen if we're out of both of them, right? So, hold on. So if we are in between the zone of the second one. Oh my god, what am I doing? What am I doing here? Yeah, if we're in the zone of the second one, right? So the second one is on top because it happened second. So 64 less than x less than 128. And 64 less than y less than 128. There we go. We Vim keybinds. Make that. Paste it. I'll just paste that. I'll manually rewrite that. So you have this one. We write color 2. Then we copy that down. Then otherwise, elif 32 to 96. 32 to 96. Then we do color 1. Else, we're not reading from memory. We're going to be writing color. Yes, we're going to be writing 000 as the color. Cool. I should probably set up some standard colors like a red, green, blue, all of that. Right? I mean, any set up standard colors. But yeah, cool. Great success. Now I just have to now I have to figure out the paths for all of these, right? So first we read the bounding box 1. Read bounding box 1. We check the first bounding box, right? If it passes, that means we're in one of these two states. Otherwise, you know, we hold on. It's ignored. We have to read both of the bounding boxes, right? So we read bounding box 1. We check bounding box 1. Yoink. No, the order for these is reversed. Yeah, the order for these is reversed because if the first one activates, no. We are just gonna go through all the shapes, right? Read bounding box 2, check bounding box 2. So, yep, we check the bounding box, and then we're gonna check bounding box 2. I mean, okay, hold on. We're going to read a bunch from memory, right? Then we're going to spend a cycle checking the bounding box. This is going to be based on, let me just delete that. Okay, so what are we doing here? First, we're reading a bounding box, right? Read bounding box 1. Hold on. We're going to figure this out. So, if we're between this, that means we've read 2 bounding boxes, right? So we read bounding box 1. We check bounding box 1. Well, we only care about the last forward, right? So we might as well just start from the last one. So we read bounding box 2, right? Type rectangle. Oh, right, hold on. That's why we had a whole bunch of zeros. I remember now. We had a whole bunch of these zeros because this is the space that we've allotted to... yeah, this is the space that we've allotted to just like extra information of like triangle vertices and whatnot. Yeah, that would make sense. I've given it just like 16 bytes. Cool. So we read bounding box. We read the second bounding box, right? So we're gonna start from the end, and then I should probably paste. Cool. So we checked at the bounding box. We know we're in there, and we read from memory. Cool. Then, cool. So that means we've checked the bounding box. We know we're not there. Then we check bounding box 1. So this is not at memory address 1. This is at memory address 4. So that's 1, 2, 3, 4, 5, 6. 6 times 4, 24 bytes in. So 0, 1 to 24. So then that would be 25. 25. 25, right? So we checked 25. Yeah, right. Check bounding box 2. Then we check bounding box 1, right? And if we, and then this we know we succeeded, and because we know we succeeded, that means we read the color and we write the color. This is not 25. This would be plus 24, so this would be 29. We read the color and we write it, and then I should probably comment this with read color. Read color. Read color. Cool. And then here we checked all of the bounding boxes and we output. Cool. So now this shouldn't be too bad. AHX. We modify this. So we're going to start. Starting state. This implies that we start immediately here. This is wrong. We need to start by reading the number of shapes, right? So where is num shapes? Read num shapes. We are in fact doing stuff here. Num shapes is UIN. And then this just goes to, so read shape bounding box 1. So this we have to send to the second one, right? So read address. Where are we writing into read address? Oh, wait, read address is a bit of memory we have, right? Yeah, read address is a bit of memory we have. Starts at 0, right? So, yep, we read the number of shapes. Then what we have to do here, num shapes is UIN. Great. So read num shapes 3. This is, we have to edit the read address in here. So read address is going to be equal to 24 star UIN, right? So we're multiplying by 24 minus 24. Right, so if number shapes is 1, minus 23, then it's going to be equal to 1. We're editing that here. No, we're not. Right, otherwise, you know, we set it to whatever is in UIN, minus 23. And then we go through, and I will, in the check bounding boxes where we have to edit it, but first, hold up. I realized I made a mistake here. Yep, there is 2 shapes in memory. 2 shapes in memory. And then up here, there's 1 shape in memory. Yep. So we're down here. And so what we do here is we have to... hold up. I am losing control of my keyboard. So what we do here is we... Yeah, so we have to check the... So in the checking of the bounding box, so we read the shapes bounding box, right, from read address. And then here, if counter is 3, yep. So if, check bounding box. So in check bounding box, if we are not in the bounding box, oh my god, this end is it's ugly. Cool. Yeah. So if we're not in the bounding box, we go straight to right color. This is wrong. We check. Not in bounding box. I will write a shapes left. I'll add a little bit of memory because why not? You know, I have as much space as I want. Reg. I'll put. I don't know. Screw it. We have all the memory. Whatever. Shapes left. So 8 bits there. And then, I mean, I guess it's num shapes. So shapes left is UI in. Cool. This is really ugly code. We need to clean it up later. And then here, check bounding box. State goes to check bounding box. What is this, man? Okay. There's probably some copy pasting nonsense going on here. Cool. State goes to check bounding box and what did I call it? I call it shapes left. Cool. Shapes left goes to shapes left -1. And so then here, if shapes left is 0, right, so there's no shapes left, that means we just write this color. And then else begin, so there are shapes left. And the next state will be read shape bounding box 1. Let me check. That's how we enter it. Yep. And then the read address. Yep. Read shape bounding box 1. It's down here. Right, so we update the read address to not be based on UI in, but it's shapes left -23. And then, did I forget semicolon up there as well? Hold up. Yep, I did. And so, yeah, and so read shapes is based on shapes left. And then if we don't have shapes left, so we do have shapes left. Yep, shape left is 1 less, so shape left, if it's 1, it goes to 1, yep. And then, and then we also have to do these two. There we go. Cool, and then from there, we have, this should not be read address. It should be read address. (24) times shapes left -23. Order of operations will save me here. I don't need to worry about any of this. Well, I do need this. And then 15:8. 15:8. There we go. 24 times shapes left -23. Cool. There we go. And then that should just be it. Color. Otherwise, we go to read color, and it's based on read address, which just naturally increments elsewhere. Okay. Okay. Make dash b waves equals 1. Error, yes. Syntax 130 and 131. 130. Yeah, okay, these are illegal. Modulo 255. Divide by 255. That legal? That is legal. Now I have Python errors because I forgot commas. Okay. That's, yeah, that I didn't touch. Here. Yup. Whoops. Fail. Where are we failing here? Failing on the first one. Why are we failing on the first one? We're failing on the first one because... well, I mean, I forgot the shapes file, so hold up. Went 2, 6, and then GTK wave, yes. File, open a new tab, tb.vcd, there we go. So that's probably a good timescale. Bang. Ignore all of that. Dump all of that. Cool, there we go. So, there's the resetting. Boom. So what is the error here? State 1, 2, 3. Bang. We are outputting 233. Why are we outputting 233? Where is 200? E9 is 233, I assume. Why are we reading FFFFE9 as the read address? HX. V. Okay, so the read address here, starting state, read address starts at 0. Read address is 24 times UIN minus 23. What is in UIN? UIN has 1 in it right now. 24 times 1. Huh. Okay, well, I'll just like left shift. UIN, left shifted by, so 24 is 16 plus 8. So 16 is 2 to the 4 plus UIN, left shifted by 8, which is 3. There we go. Still fails. Oh my god. Refresh. Okay, still doing its thing. Okay, that's, huh. It's going to 233 both times. Even though here we're inputting 2. So this means it's not actually being based on what's in UIN. Right? Read num shapes. What is the value inside of num shapes? It's written 0 here, which is wrong. It is not changing. Right? So num shapes. So this is state. Let me just double check the numbering I did here. Yep. 0, 1, 2. So end of state 2. So end of state 1. So during state 2, yep. Then this 1 should be transferred from UIN into num shapes, which it is not. Why? This 1 read num shapes 2, okay. Why is this failing? And obviously read address. So I'm just going to return this back to the multiply by 24 because that's exactly what's going on. 24 times. Cool. And this is read num shapes 3. Yup, this is going right down. Yup, we should be reading the number of shapes. Num shapes is UIN. Yup. This all checks out. Why does read address go bonkers here? Hold on, let me just comment this out and set read address to like 36. This is obviously going to fail, but we're outputting 36. This is correct. 2, 4. That is 36. So sure. Okay, so that's very strange. So this is, in fact, doing stuff. So 24 times UIN minus 23. Why is UIN some number that makes no sense? UIN is 1. Can I have this bit go right? Yes. There we go. UIN is 1. We know it is 1 here. Shapes left goes to 0. Num shapes is 0. Why is it 0? Why is it not updating? Should be the value in UIN. Because read num shapes 2. State 1, we given the read address. State 2, we given UIN. Right? State 3, and we go to that read address for shape bounding box 1. It should change for state 3. State 3. It's not correct in this state. Oh, let me just rerun it so we have the current one. Yep, there we go. Still failing. There we go. You are out. What? Read address. Yep, so we're outputting to the right spots. Yeah. But why is this failing? Why is our read address not actually 24 times UI in? Right? So on this clock signal, it should be this number times. It should just be that number. Right? So it should just be that number times 24. 1 times 24 is 24. Minus 23 is 1. Read address should be 1. Why is it not 1? Okay, well then let's just multiply by 24 and not subtract 23. What happens then? Yup, okay, still failing. This is expected behavior. It's 0. Because UI in is 0? It's reading UI in as 0? Okay. UI in is an input, right? Yeah, UI in is an input wire. Okay. It's whatever values in UI in minus 23. It is not actually reading from UI in is the problem. Okay. I mean, in this state, we output the read address we want. And then, there we go. We get the stuff in UI in, which goes into our 3 bits of data. Right. And hold on, in right color 3, we should probably, because we're going to the next pixel, so I should probably reset shapes left to be num shapes. Just so we have that out of the way, just preemptively. Okay, so what is going on here? So UI in is not a real value. I mean, we know it's a real value because it like works here. Right? Like, what? We should be updating it here. Right? Hold on. When does this change? If I... Yeah, okay. Let's rerun it. And let's see when it changes. If it changes over here. So we're reading the UI in from state 1. This does 0 1. Yeah, no, this doesn't make sense. So you have to delay this by another state. Yes, so in state 2, right, because the number gets subtracted by 1, state here, so it goes 0 1 2. We need to have UI in active earlier, which makes no sense. So we need to push these 3 later. Okay, sure. Still failing. That's fine. Shapes left. Oh, there we go. Nice. And so then I need to bring in the minus 20. Okay, then. What is failing here? We are outputting 0 when we should be expecting 1. This is a fair concern. Read address is in fact 1 here. But the problem is, as we see here, this is just all not updating properly, which, yeah, checks out. Yeah, okay, so paste that back. Okay, so we need to bring forward the editing. Where is it? Yeah, so read the number of valid shapes, which is 3. So read from memory. I mean, it's a standard memory read, right? So check, output enable, clock, check, output enable, data, clock. Seems fully legit to me. Oh, hold on. That checks out. HX dot because we have what? 1, 2, 3. What happens in bounding box 3? Hold on. We're reading in bounding box 3? Oh? Okay, what's in bounding box 2? Bounding box 2 does nothing. Read color 2? Okay, we just increment the read address. Okay, sure. Okay, this is how it is intended to be, and I just didn't update it. Okay, sure. Paste it in here. And also you have to, we can't use read address here. I'll just copy the thing I did here. Yep. And then I'm just gonna paste that in here, up a little bit more. Where we're here. I'm gonna paste that down here. XXD. Cool. And there we go. We fail again, but that's because it doesn't know what it wants to output here. That's a good sign. No, it's not. But, you know, we can figure that out. Modulo is, I mean, shapes left. I mean, I'm just gonna HUD code 0 in here, right? Like, whatever. Why does it not know what it's trying to do? Oh, it can't be shapes left. It has to be UI in here. Yep. Okay, well, UI underscore in, and at the end I'm going to throw in a modulo 256. And I'm just going to paste that, well, rewrite it. UI in minus 23, and then here divide by 256. Oh, we're running. There we go. Cool. So, yeah. It's going to fail on the second test. We know this, right? But, and here's the big but, it'll fail later on the first test. Okay, how long does it go for normally? We can find out. Well, we'll get a real-time estimate when this finishes, right? But this is a good sign. Yes, we did fail the second one. The real-time estimate is 22 seconds per test, roughly. Cool. We failed the second test. Where did we fail the second test? I'll just check here. Refresh. There's where the reset signal goes. So here's the second test. And why are we failing it? So read address goes to 1A. I mean, this is all legit. And it falls back. 2, 3, 4, 5. And then we go to read address 1. Yes. Makes entirely legit sense. State 1, 2, 3, 1, 2, 3, 4, 5, 3. So 1, 2, 3 is read number shapes, and 4, 5. So, yeah. 3, 4, 5, 3, 4, 5, 3, 4, 5, 3, 4, 5. Expected. Shapes left 1, 6. So that's checking the number of the bounding box. We fail. 3, 4, 5, 3, 4, 5, 3, 4, 5, 3, 4, 5, 0. So then we go to right color. 3. And then we go back to state 3 with 2 shapes left. The problem is that we don't actually update it when we go back. Right color, yep. Shape left is num shapes. And the read address is wrong here, right? So the read address here should be num shapes 24 times num shapes. 24 times num shapes minus 23 modulo 255. And then the same thing for here. 24 times num shapes minus 23 modulo 255. Cool. And then we make it. We failed that. Why are we failing test 1 again? A little bit early to fail test 1, you know? You know how it is? Yeah. So, let's go here. Let's refresh this. Failing test 1. Why are we failing test 1? 3, 4. We're attempting to read 25. 25 right. Oh, rip. Did I? Yeah, I did modulo instead of divide. Whoopsies. And it should be modulo 256 divide 256. Cool. Cool, there we go. Now we're running it again. We are successfully running the tests. Great success. Actually, amazing success. You know, this is great. This is going very well. Yeah, cool. And so then from here, we have to wait. Again, it's going to be like 40 seconds. But yeah, fail the second one a little bit later. 2 equals 26 modulo 256. Very interesting. At the end, there's a reset. We do frame stage 1. Bang, stage 2. Read address. Read address is not properly updated. Right, so the read address. So we write the color and read. Where are we doing this? Like we write the color and then read shape bounding box 1. Read shape bounding box 1. We just go based on read address. Okay. Cool then. Where are we editing read address here? We're not. (24) times num shapes minus 23. I need to fix the spacing on all these. Cool. Semicolon. Cool. There we go. The problem is that read address was somehow working for only one shape, which is strange, but it is what it is. It is what it is, as it is. And then, yeah. So then... Oh, I had to rename the file into multiple shapes. The file is based on the original file. We will figure it out when we figure it out. Yeah. So we passed the first one. Great success. Warnings. We have the file is unclosed. It ran a decent amount of the way, and then when we were outputting something, it was wrong. Cool. So line 176. Okay. So it's still here as failing. Strange. I'll rename this multiple square test. Cool. So this is failing. Why is this failing at the very end? We do go for a whole lot longer though. 456, 456. 2 shapes, 1 shape, 0 shapes. 6, 7. What is our current pixel? Current pixel 6020 804 804 6020. Yeah, sure. Current pixel is 1020. So 20 matches. Hold on, let me data format binary. Cool. 1 2 3 4 5 6 7. Yep, that is a valid 20. 1 2. That's also another valid 20, so that's 3 2. Right, so we should go here into read color, yup. And so we'll read color on read address of 5, right, because it's the first shape, right, because that's in the center. So 3 4, so 1 2 3 4 5. And then we should be reading from 5. Why is reading from 5 wrong? It's because I have my test is wrong. In the single case, because we have equal to should be valid here, right? So in the single square test, I have equal to is not valid. as there. So this should be an equal to. Equal, 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 equal. Cool. Equal, equal. Equal, equal. Cool. There we go. Now let me edit the single test just to make sure this all works. Yeah. And let me do it in the format. So it's 32 less than equal to x less than equal to 96. And 32 less than equal to y less than equal to 96. Then x1d paste xd paste xd paste. Cool, there we go. So we've read the writing. I probably should bring this into both, but it is what it is. Yeah, cool. Make dash b waves is 1. And so if this works, that means we've probably succeeded. And it was the equals issue. Yeah, I think it is the equals issue, right? So once this works, we will have successfully rendered multiple shapes. So obviously the single square test, this is only one shape, right? And then, yep, it passed. So theoretically, this means that we can render multiple squares, multiple shapes. And then tomorrow, we will get a triangle working, right? So maybe not tomorrow. Next stream. Next stream we get the triangle working. This stream, we're single square test. We're running it as you do, and it looks like it's going great. Right, this is a great sign. 20 seconds field time. I'm actually curious what the simulation time is, because if the simulation time is what we expect, because again we're IO limited here, right? So yeah. Oh, there we go. Hey, single square test passed. Oh, the multiple square test is passed as well. Nice. So choose file. Multiple square test. Select. There we go. We've rendered 2 squares. We have successfully rendered 2 squares. This is a great success, honestly. We've got multiple squares rendering. And, yeah. So we've succeeded. We've succeeded in rendering multiple squares. Now, let's have some fun, shall we? Let's have some fun. HX has... pi. Cool. There we go. So we're rendering 2 squares, and then everything is working exactly as we expect. Yeah, we should do some randomization here. Alternatively, rendering multiple squares test. Single square test. Cool. Honestly, that's a success. We rendered multiple shapes today, and I'm going to leave it at that for today. Thank you all for joining me today. I will see you all next time for the next installment, where we're going to be rendering a triangle. Thank you very much. See you guys. Goodbye.